The Panther is a German medium tank deployed during World War II on the eastern and western fronts in Europe from mid-1943 to the war's end in 1945. It had the Ordnance Inventory designation of SD.KFZ 171. It was designated as the Panzerkampfwagen V Panther until the 27th of February 1944, when Hitler ordered that the Roman numeral 5 be deleted. Contemporary English language reports sometimes refer to it as the Mark V. The Panther was intended to counter the Soviet T-34 and to replace the Panzer III and Panzer IV. Nevertheless, it served alongside the Panzer IV and the heavier Tiger I until the end of the war. It is considered one of the best tanks of World War II for its excellent firepower and protection, although its reliability was less impressive. The Panther was a compromise. While having essentially the same engine as the Tiger I, it had more efficient frontal hull armor, better gun penetration, was lighter and faster, and could traverse rough terrain better than the Tiger I. The trade-off was weaker side armor, which made it vulnerable to flanking fire. The Panther proved to be effective in open country and long-range engagements, but did not provide enough high explosive firepower against infantry. The Panther was far cheaper to produce than the Tiger I, and only slightly more expensive than the Panzer IV. Key element of the Panther design, such as its armor, transmission, and final drive, were simplifications made to improve production rates and address raw material shortages. The overall design remained somewhat over-engineered. The Panther was rushed into combat at the Battle of Kursk despite numerous unresolved technical problems, leading to high losses due to mechanical failure. Most design flaws were rectified by late 1943 and the spring of 1944, though the bombing of production plants, increasing shortages of high-quality alloys for critical components, shortage of fuel and training space, and the declining quality of crews all impacted the tank's effectiveness. Though officially classified as a medium tank, its weight is more like that of a heavy tank, as its weight of 44.8 tons puts it roughly in the same category as the American M26 Pershing, 41.7 tons, British Churchill, 40.7 tons, and the Soviet IS-2, 46 tons, heavy tanks. The tank had a very high power to weight ratio, however, making it extremely mobile regardless of its weight. Its weight still caused heavy tank-esque problems, however, such as an inability to cross certain bridges. A mild steel prototype of the MAN design was produced by September 1942 and, after testing at Kummersdorf, was officially accepted. It was put into immediate production. The start of production was delayed, mainly because of a shortage of specialized machine tools needed for the machining of the hull. Finished tanks were produced in December and suffered from reliability problems as a result. The demand for this tank was so high that the manufacturing was soon expanded beyond MAN to include Daimler-Benz, Berlin Marinefield, former DMG plant, Maschinenfabrik Niedersachsen Hanover, MNH, subsidiary of Essen Werkswalfel/Hanomag, and Henschel & Son in Kassel. The initial production target was 250 tanks per month at the MAN plant Nuremberg. This was increased to 600 per month in January 1943. Despite determined efforts, this figure was never reached due to disruption by Allied bombing and manufacturing and resource bottlenecks. Production in 1943 averaged 148 per month. In 1944, it averaged 315 a month, 3,777 having been built that year, peaking with 380 in July and ending around the end of March 1945, with at least 6,000 built in total. Frontline combat strength peaked on the 1st of September 1944 at 2,304 tanks, but that same month a record number of 692 tanks were reported lost. Allied bombing was first directed at the common choker point for both Panther and Tiger production, the Maybach engine plant. This was bombed the night of 27/28 April 1944 and production was halted for 5 months. A second factory had already been planned, the Auto Union Sigma plant, the former Wanderer car factory, and this came online in May 1944. The targeting of Panther factories began with a bombing raid on the DB plant on the 6th of August 1944, and again on the night of 23/24 August. MAN was struck on the 10th of September, the 3rd of October and the 19th of October 1944, and then again on the 3rd of January and 20/21 February 1945. MNH was not attacked until 14 and the 28th of March 1945. In addition to interfering with tank production goals, the bombing forced a steep drop in the production of spare parts, which as a percentage of tank production dropped from 25 to 30% in 1943 to 8% in late 1944. This compounded the problems with reliability and the numbers of operational Panthers, as tanks in the field had to be cannibalized for parts. The cost of a Panther tank has been given as 117,100 Reichsmarks, RM. Citation needed. This compared with 82,500 RM for the Stu G3rd, 96,163 RM for the Panzer III, 103,462 RM for the Panzer IV, and 250,800 RM for the Tiger I. These figures did not include the cost of the armament and radio. Using slave labor on the production lines greatly reduced costs, but also greatly increased the risk of sabotage. French army studies in 1947 found that many Panthers had been sabotaged during production. The Germans increasingly strove for production methods that would allow higher production rates and lower cost. By comparison, the total cost of the early production Tiger I in 1942 to 1943 has been stated to be as high as 800,000 RM. The process of streamlining the production of German armored fighting vehicles first began after Speer became Reich Minister in early 1942, and steadily accelerated through to 1944. The production of the Panther tank coincided with this period of increased manufacturing efficiency. At the beginning of the war, German armored fighting vehicle manufacturers had employed labor-intensive and costly manufacturing methods unsuitable for the needs of mass production. Even with streamlined production methods, Germany never approached the efficiency of Allied manufacturing during World War II. The weight of the production model was increased to 45 tons from the original plans for a 35-ton tank. Hitler was briefed thoroughly on the comparison between the MAN and DB designs and the report by Guderian's Tank Commission. Armor protection appeared to be inadequate, while the motor mounted on the rear appeared to him correct. He agreed that the decisive factor was the possibility of quickly getting the tank into production. On the 15th of May 1942, Oberst Fichtner informed MAN that Hitler had decided in favor of the MAN Panther and ordered series production. The upper glacis plate was to be increased from 60mm, 2.4 inches, to 80mm, 3.1 inches. Hitler demanded that an increase to 100mm, 3.9 inches, should be attempted, and that at least all vertical surfaces were to be 100mm, 3.9 inches. The turret front plate was increased from 80mm, 3.1 inches, to 100mm, 3.9 inches. The Panther was rushed into combat before all of its teething problems had been corrected. Reliability was considerably improved over time, and the Panther proved to be a very effective fighting vehicle, but some design flaws, such as its weak final drive units, were never corrected. The crew had 5 members: driver, radio operator, who also fired the bow machine gun, gunner, loader, and commander. Initial production Panthers had a face-hardened glacis plate, the main front hull armor piece, but as armor-piercing capped rounds became the standard in all armies, thus defeating the benefits of face hardening, which caused uncapped rounds to shatter. This requirement was deleted in March 1943. By August 1943, Panthers were being built only with a homogeneous steel glacis plate. The front hull had 80mm, 3.1 inches, of armor angled at 55 degrees from the vertical, welded but also interlocked for strength. The combination of well-sloped and thick armor meant that heavy Allied weapons, such as the Soviet 122mm A-19, 100mm BS-3 and US 90mm M3 were needed to assure penetration of the upper glacis at all combat ranges. The armor for the side hull and superstructure, the side sponsons, was much thinner, 40 to 50mm, 1.6-2.0 in. The thinner side armor was necessary to keep the tank's weight down, but it made the Panther vulnerable to hits from the side by all Allied tank and anti-tank guns. German tactical doctrine for the use of the Panther emphasized the importance of flank protection. 5mm, 0.20 inches, thick-spaced armor, known as Scherzen, intended to provide protection for the lower side hull from Soviet anti-tank rifle fire, was fitted on the hull side. Zimmerit coating against magnetic mines started to be applied at the factory on late OSF-D models beginning in September 1943. An order for field units to apply Zimmerit to older versions of the Panther was issued in November 1943. In September 1944, orders to stop all application of Zimmerit were issued, based on false rumors that hits on the Zimmerit had caused vehicle fires. Panther crews were aware of the weak side armor and made augmentations by hanging track links or spare road wheels onto the turret and/or the hull sides. The rear hull top armor was only 16mm, 0.63 inches, thick, and had 2 radiator fans and 4 air intake louvers over the engine compartment that were vulnerable to strafing by aircraft. As the war progressed, Germany was forced to reduce or no longer use certain critical alloys in the production of armor plate, such as those including nickel, tungsten and molybdenum. This resulted in lower impact resistance levels compared to earlier armor. Allied bombers struck the Naben mine in Norway and stopped a key source of molybdenum. Supplies from Finland and Japan were also cut off. The loss of molybdenum and its replacement with other substitutes to maintain hardness, as well as a general loss of quality control, resulted in an increased brittleness in German armor plate, which developed a tendency to fracture when struck with a shell. Testing by U.S. Army officers in August 1944 in Isigny, France showed catastrophic cracking of the armor plate on 2 out of 3 Panthers examined. The main gun was a Rheinmetall Borsig 7.5cm KWK-42 L/70 with semi-automatic shell ejection and a supply of 79 rounds, 82 on OSF. G. The main gun used 3 different types of ammunition: APCBCE, PZGR-39/42, D, SBR-GR-42, and APCR, PZGR-40/42, the last of which was usually in short supply. While it was of a caliber common on Allied tanks, the Panther's gun was one of the most powerful of World War II, due to the large propellant charge and the long barrel, which gave it a very high muzzle velocity and excellent armor-piercing qualities. Among Allied tank guns of similar caliber, only the British Sherman Firefly conversion's Ordnance QF-17 pounder gun of 3-inch, 76.2mm caliber, and a 55 caliber long, L/55 barrel, had more potential hitting power. The flat trajectory also made hitting targets much easier, since accuracy was less sensitive to errors in range estimation, and increased the chance of hitting a moving target, though these same attributes made the gun a poor infantry support weapon using HE ammo. The Panther's 75mm gun had more penetrating power than the main gun of the Tiger I heavy tank, the 8.8cm KWK-36L/56, although the larger 88mm projectile might inflict more damage if it did penetrate. The tank typically had 2 MG-34 armored fighting vehicle variant machine guns featuring an armored barrel sleeve. An MG-34 machine gun was located coaxially with the main gun on the gun mantlet. An identical MG-34 was located on the glacis plate and fired by the radio operator. Initial OSF-D and early OSF-A models used a litterbox flap enclosing its underlying thin vertical arrow slit-like aperture, through which the machine gun was fired. In later OSF-A and all OSF-G models, starting in late November early December 1943, a bull mount in the glacis plate with a KZF-2 machine gun sight was installed for the hull machine gun. Panthers were supplied to form Panzerabteilung 51, Tank Battalion 51, on the 9th of January, and then Panzerabteilung 52 on the 6th of February 1943. The first production Panther tanks were plagued with mechanical problems. The engine was dangerously prone to overheating and suffered from connecting rod or bearing failures. Petrol leaks from the fuel pump or carburetor, as well as motor oil leaks from gaskets, produced fires in the engine compartment, which resulted in the total retirement of 3 Panthers due to fires. Transmission and final drive breakdowns were the most common and difficult to repair. A large list of other problems were detected in these early Panthers, and so from April through May 1943 all Panthers were shipped to Falkensee and Nuremberg for a major rebuilding program. This did not correct all of the problems, so a second program was started at Grafenwohr and Erlangen in June 1943. Reliability improved with the OSF and later G of the Panther, with availability rates going from an average of 37% by end of 1943 to an average of 54% in 1944. By mid-1944, the Panther was at its peak performance and widely regarded as the most formidable tank on the battlefield.